Okay. In last session, we discussed about different relationships and also the storage modes. Different storage modes that are available in SSIS, and also what are the advantages of each one and the disadvantages of this of each storage mode we have in SSIS. Today, we're gonna see one important concept. This is not the important one. In the sense like without this you can create a cube, but with this the performance of the cube will be too good. Okay, performance in the sense we have to see the performance in two ways. One is processing way and another one is querying way. Let's see everything in today's session. First, performance. What kind of performance problems you may encounter in SSIS cubes? There are two types. One is querying the cube and another one is processing the cube. Okay, better I'll take a plain page. Fine. Let's say this is your data warehouse where you are having some 50 crore of records. Okay, and this is your solution and this is your analysis services. So if you select MOLAP storage mode, okay, what MOLAP will do? MOLAP will read the data from here to here, the complete data, and after reading it will create aggregations here and also indexes. So this is the job of MOLAP storage mode. If you have this as relational database and this is your analysis services. Now imagine if the analysis services execute or read 1 lakh records per second. That is the best, right? 1 lakh records per second. How many seconds it will take to read 50 crores of data? So 50 crores of data, I can say it is gonna take 1 lakh 1 second. So 100 seconds for 1 crore and 5 crores 500 seconds and 50 crores 5000 seconds to read the data. 5000 seconds is close to 1 hour something, right? That is just to read the data, the first task. So for reading this data, it will take close to 1.5 hours. And remember, 1 lakh records per second is the best case. Sometimes if the relationships that you have given is too complex, then it will read something around 20 to 30,000 records per second. Then the time grows, then the time will be increased even further, like 3 hours or 4 hours just to read the data. After reading the data, let's assume it takes half an hour to create the aggregations and indexes. So the best case is 2 hours, right, to read the data. So this is performance problem. If for 50 crore records, if it is going to take 2 hours to 5 hours, something like that, then the performance is poor. This performance, we call it as cube processing performance. Processing performance should be good. Okay. So this is one place where we will worry about the performance. The second place is querying of the cube. Once the data is pulled into this and the aggregations are created and the cube is ready to query, we will use MDX to query the data, right? MDX to query the data. So generally we are going for this SSIS cube to increase the performance, or else we can query SQL Server database itself, like we can query here itself. The reason for going with this SSIS cube solution is to improve the performance. After creating the cube, if MDX is taking time to generate, return the result set, like if I'm trying to pull 1 million records and if it is taking 30 seconds or 1 minute, that is also pretty high as per the SSIS concepts are concerned, SSIS software is concerned. So I've read an article recently, in that it mentioned like if you design the cube in the best way, I'm stressing the word the best way, then none of the MDX queries should take more than 2 seconds, should not take more than 2 seconds. Okay, so all the queries should return the data within 2 seconds. That's what that article is saying, but ignore that. I mean, no way, we cannot do that. All the queries returning in 2 seconds, it's impossible 10 seconds. So what we have to do is we have to try our best to improve the performance. The performance should be good. It should be in control. So in two places we have problem. One is while processing the cube, that means reading the data from OLTP to OLAP, and the second thing is reading the data while generating the reports. You will use MDX to generate reports, right? Or to pull the data. So while generating the reports, the query should return the data faster. So how can we increase the performance? How can we improve the performance? One of the option is partitions. I cannot write full thing here. I'll write that means partitions. Okay, partitions will improve the performance here, the query time, sorry, the processing time, and also query time. Okay, first let me explain about how to create the partitions and what is partitions, for which tables we can create partitions, and so many factors are there. So first let's discuss about all those stuff, and once you get complete knowledge on the partitions, then we can come back and see how it will increase the partitions for the querying the data to querying the data using MDX and reading the data from OLTP. So for that, let's take SSA solution. You can see a separate tab for partitions. In the partitions tab, if you have, if in the partitions tab, if you see, there will be one partition created for every measure group. Okay, for every measure group, you can see one partition created. I created 3 measure groups. You can see sales, book sales, and auth books. You can see 3 default partitions created. So for every measure group, a default partition will be created. You cannot create a measure group without having at least one partition. Remember that. At least one partition is mandatory per measure group. Okay. Now, let's take this partition, the sales. What is meant by partition here? Partition will tell the server, okay, that whether it has a table or list, set of tables to load the data. This is your analysis services, and this is your OLTP. If you have one partition here, it will create one connection to the OLTP, and it will read the data from here to here using this channel and paste it into this partition. So the default partition. If you have more than one partition for the same measure group, then it will create multiple ways. I mean, using multiple connections at a time. So partition is nothing but the storage where this data that is being pulled for that particular measure group needs to be stored. By default, there will be only one partition defined, and that partition is, we call it as default partition. And if you see the source of the partition, you can click on this, and if you see the source of the partition, you can see it is table binding. Table binding in the sense, table to table link. The table in the source will be linked to table in the destination. This is your source table, that is OLTP database table, and this is your analysis services. So table to table means pull all the data from the table and push it to this table. That's it. This is your OLTP and this is your OLAP. Okay. So this is table binding. Only one connection will be set. The complete data from the table. It is like select star from employee. That means it will read all the data from the employee table and return you and store in the analysis services. So this is the default one. So the default one is table binding, which means it will pull all the data from the table and then push it into the server. Now, what is the next option available? The next option is query binding. Query binding will help you in filter the data. It won't pull all the data like select star from employee. It will filter some information and it will set one connection. Let me explain you a couple of creating a couple of partitions, how to create partitions and all, and then we'll come back what is this query binding and table binding again. You should be familiar by after we create some partitions. So whenever we want to go with partitions, first thing that you have to do is you have to change this table binding to query binding. You should not have any table binding. If you have table binding, that means this particular storage part in the analysis services with the table binding partition will pull all the records into the analysis services. Then I don't need another one, right? What is our job here? Our job is to pull the data, all the records from your fact table to measure group table to analysis services. If this one is having table binding, this one will pull everything from here to here, right? Table binding means select star from table name, full data. So I cannot create one more partition and give the link here, right? The problem is I'll get the same data twice, one time here and one time here. So the first and foremost thing you have to do is you have to remove this table binding. You should not get the complete data. What you have to do, you have to remove the table binding and filter some data like only first top 10 or top 1000 records and push it into this partition, and then next 50 to 100 million records into second partition and create one more partition if you wish, and the remaining data into the remaining one, the third one. So what I'm doing, I'm splitting the data and pushing into different destinations. Okay. Now let's see how to do that. When I select query binding, you can see it is showing query. This is the one which it was showing table binding, and where it has to look for the table. The table is present in this data source view. This is fine. And what is the table? The sales. If you click on OK, the complete table will be pulled into this partition. Instead of that, if you go for query binding, you can see it is asking for a where condition, where let's say sales amount greater than 500. If I click on OK, this particular partition will pull only the data where the sales amount greater than 500. So how many records will come into picture with the sales amount greater than 500? Let's see that one in query analyzer. I'm connecting to the database here. So our database is AdventureWorks DW. So earlier it was table binding. That means select star from fact internet sales. So this one will pull all the records in one step. That is 60,398. Now what I have done was I set some filter, means I changed it to query binding part, where sales amount greater than 500. This is the one I have given, right? So if you see, I am getting only 15,205 records. So I am not pulling all the records into one partition. I am pulling only set of records into one partition. So let me process this now. Let me process only this partition. How can I process only one partition? This is how. Right click and click on process. Let's see how many records it is going to pull into the analysis server. And you can see the storage mode is set to MOLAB. So it is deploying. Fine. You can see only that partition is processed and it read only 15,205 records. Right? It's pretty clear that this partition is reading only some data after filtering based on the condition we have given. So this is one partition. I created one query binding partition. Now, what is the problem? the remaining data will be missed. For that, I have to create one more partition. If I click here, it will open the partition, creating new partition wizard. Click on next. This is your measure group table. Well and good. This is the table you have, right? This is the measure group name, and this is the table, source table for the measure group. Click on next. Specify a query to restrict rows. If you don't specify this, then it will become table binding. If you specify this, it will become query binding. You can see where sales amount less than 500. So the earlier case was sales amount greater than 500. Now the sales amount is less than 500. You don't worry about these locations where you can store this partition data. You can set the storage in a particular location that you wish to. For example, if you see current server instance means where the analysis server is installed, the partition data will be stored there. Remote analysis service data source means you can specify a new one. There it will go on store the information, right? So leave this one for now and set the default location. Why? Because 99.99% of the cases people want to store the data where they have the analysis services installed. And you can see this is processing location. Sorry to say this. This is the storage location. By default, it is taking this path. You can see files, Microsoft, SQL Server, something blah blah, and so on. If you select a specified folder, it will go on store the data here. If the folder where you have the SQL Server installation is full, and if you have less memory, then you can specify your folder to different drive. Okay, this is the option. Now click on next. This is aggregations part, complete aggregations part. You can see there is a separate tab for aggregations. We are going to discuss about it. So there are three different options. One is design aggregations for the partition now. I don't want to do that now. I will do it separately. And next option is design aggregations later. This is what I want. Okay. Copy the aggregation design from the existing partition. No, I don't have anything. So leave it. Once we discuss about aggregations, then you will come to know about the first and last option. And deploy and process now. No, I don't want to do that. I created one more partition where I'll pull only the records which are greater than, whose sales is less than 500. Now, let me process this particular partition alone. Meanwhile, let me write the query. Sorry. For less than, sales amount less than 500. You can see it is written for returning 45,193 records. Let's see how many these analysis services will return. This is done. It is not showing. Sometimes it won't show. There is a problem with analysis services. This is the problem. Let me do one thing. Let me close and reprocess it. This problem is there with the server here. Nope, it is not showing. I'll do one thing. I'll process the complete cube so that you will get the information. I'll show you that, okay, whenever you process the information. So I created two partitions. What I have done by creating two partitions, what I have achieved. So earlier, sorry, it was table to table, table binding. Now I changed it to query binding. I split this data into two, one into this partition and one into this partition. What is the advantage of splitting the data into two? Let's say, for example, this pipeline is reading 1 lakh records per second. Now what will happen is this one will read 1 lakh and this one will read 1 lakh per second. So the performance will be improved, right? So this is why the partitions plays a major role in improving the queue processing performance. So if you don't define the partitions properly, then you will suffer with the queue processing performance whenever you move the queue to the production. Whenever you are working on development data, they will give only 10% of the data. Clients will give only 10% of the data. So your processing of the queue will be super fast. But when the full data comes into picture, then your queue will take lots and lots of time to process. So always good practice to create the partitions, and this is how you can create partitions. For creating the partitions, you have to be very careful. Now we have created 2 partitions, and if you think this is fine, if you think these 2 partitions are fine, then you are wrong. Why? Because if you see the first query I have created, it is sales amount greater than 500. If you see the second query, it is sales amount less than 500. And if there is any record that is equal to 500, see there are some sales amount is equal to 500. Okay, there is no records luckily, but if any record is there, that will not come into picture, right? That one will not be pulled into analysis services. So whenever you are creating partitions, the first and foremost thing you have to look is there should not be any table binding. And the next thing is not even a single record should be missed from your measure group table. You should not miss even a single record as per your requirements. Your requirement says that you have to get all the records from the fact internet sales, that is 60,398 records. You have to create 1,000 partitions if you wish to, but you have to make sure that all the records are pulled into the analysis services. So what is the missing part here? The missing part is the condition equal to 0. So let's add that one too. Today there is no data for equal to 0. Sales amount is equal to 500. Today there is no data. That is fine. But what if in future the data is data is added? Then the data will not be pulled, right, with the conditions what we have given in the remaining 2 partitions. So it's my job to take care of all the possibilities of getting the data. Sales amount is equal to 500. So I don't want to create aggregations now. So done. And it's always whenever you're creating the partitions, it's your job to take care that give the proper naming, use the proper naming conventions for the partitions name. Sales data with sales greater than 500. So the next one is sales less than 500, right? And the third one is equals to 500. So the partition name should give the proper meaning what this partition is, what is the condition or filter part you have given in this partition. Okay, sales data with sales greater than 500, sales less than 500, and sales equals to 500. So this is how you have to create partitions. We have discussed 2 important points. One is no table data, and another one is not even a single record should be missed from your OLTP. And the third important one is no data should be duplicated. For example, if this is greater than 500 and this is less than 500, this is equal to 500. If by mistake, if I give it as greater than or equal to 500, what will happen? I will get the equal to part which is here, which will be pulled here, also will be pulled in the second one, that is greater than or equal to. So greater than or equal to will pull the same data that is being pulled by equals to 500 partition, the first partition in this case. So this is one important point to keep in mind while creating the partitions. No extra record should come into picture and no record should be missed. So this is the important principles while working on partitions. I would like to explain a funny incident happened in my life, okay, in my software life, that too particularly Microsoft BI life, in particularly SSAS career. Okay, so I was working for a company very good client. I was working for the client. So my manager assigned me some task. I was working on the task. I was busy on those tasks. Okay. My colleague got some work on creating partitions. My manager asked him to create 3 partitions. And this guy, just like this, you can see 3 partitions here, right? Similar to this. This guy has taken 3 days to create 3 partitions. Okay. At the end of the first day, I was sitting next to him. Manager came to him and asked him, what is the status? The, he he expressed, I mean, he has given the status in such a way that that guy, manager, believed that creating partitions is the biggest and toughest job. He said like, somehow I finished 1 partition today. I'm trying my best to finish another one. I'm in the middle of the second one. When the manager asked him next day, he said, I completed the second one and third one is almost all coming to an end. So creating 3 partitions is a matter of 2 minutes, right? So he has taken 3 days. The problem is the manager is not technically sound. So this is how people will be. That still, I mean, whenever I think about this, I'll feel okay. People are like this. I mean, it's funny incident for me happen in my life. So even you can say for creating partitions, you can take 3 to 4 days. But if the manager is not technically sound, okay. So we created 3 partitions and all the principles are checked here. That is no table reference and no duplicate data and no records are missing from the fact table. So all the conditions are set. This is how you can create the partitions. What is the difference between having table binding and query binding? Table binding is like giving a tank of water to you, okay, and asking you to release all the water into a tank, another tank, using 1 pipe. It will take only 1 pipe. So if you create partitions, this is the same job, emptying the tank to different tanks or to the same tank using different number of pipes, 3 to 4 pipes. Which one will be faster? Which one will be completed first? Obviously the one which is having partitions. So it's just like sucking the juice or sucking the coconut water using 1 straw and using 3 straws. Which one will complete faster? Obviously when you have more than one, right? So this is how the partitions increase the processing speed. The processing time will be reduced. Like if it takes 3 hours with 1 partition, that is table binding partition, if you create 10 to 15 different partitions, then it will take less time to read all the data from your OLTP to OLAP. Now you should not create partitions like I have done here. This is the worst way of creating partitions. If you see here, the way I created the partitions, this is the worst way I can say. Why? Because I have given some condition like greater than 500, less than 500, equal to 500. No one will go for that. Partitions generally, they will be created based on dates. 90% of the cases based on dates. And 10% based on products or how frequently people, I mean, what is the column on which people frequently queries the data. Okay. Let me remove this data. Let me remove these partitions. Delete. Delete. And I'm deleting all the partitions. Okay. Now there is no partition for this. You can see here. This is the one. Define partitions for measure groups. The measure group has 0 dimensional overlap with all the measure groups in the cube. So it has no partitions. Now let me tell you what is the best way of creating the partitions. If the user see the data frequently based on dates, generally in analysis services, I mean in data warehousing concepts, people frequently sees the data like this. This month sales to last year same month sales, whether it is increased or decreased. Or this quarter sales to last year same quarter sales. Or this year sales to last year sales. Or this week sales to last year same week sales. So people always go for month on month. Month on month means this month to last year same month, or year on year, quarter on quarter, semester on semester, week on week. So data warehousing, people mostly use date wise calculations. Okay, date wise they will do their analysis. Or secondary, big companies, big telecom companies, what they will do is they will have so many offers, right? Plans, I can say. Student 199 plan, what is the sales? Student 99 plan, what is the sales? So they used to see the data plan wise, which plan is having great demand in market. If you take LIC India, Jeevan Anand is pretty famous. So the person who analyzes the business of LIC, he'll come to know Jeevan Anand, the best one in all the LIC policies. So he will release similar one or with some add-ons to the Jeevan Anand policy. So this is for analysis and making the better decisions, right? So whatever the most frequently, based on what data people always like to see or analyze their business, you have to create partitions on that particular column. As I told you, 99% of the cases people see the data, people try to analyze their business based on date column. Okay. Now let's see what's the best way. As I told you, most of the cases people go for dates. Now let's try to create a partition based on dates. What are the different dates that are available in my fact internet sales? We have ship date, due date, order date, right? You can use any one. You cannot use all three, any one thing. Which one you want to use? Let's go with order date. Okay. So simple thing, what we have to do is where order date key is equal to something. 1, 2, 3, 4, 5 that is present in the table. But what is the meaning of 1? What is the meaning of 2? What is the meaning of 3? What is the meaning of 4? You don't know all these things, all this stuff, right? You can get to know about all these things only when you join this one with dim time key. So for example, inner join dim time, I'll call it as A on A dot time key is equal to fact internet sales dot order date key. Now I've joined where order date key is equal to 1. Okay. Let's see what is the year and the information that it is gonna get. Why this column is, sorry, it's B dot. So I don't have year information here. What I have is only keys. Everything is stored in the form of keys. That's why I'm joining with the dim time table to know what is this month and year. So it is calendar year 2001 information. Order date key is third quarter, second semester, 7th month information. So what I can do here, instead of going for this calendar year is equal to 2001, it will fetch me all the 2001 data, right? You have 1013 records. You can see at the bottom. So what I'm doing here, as I don't have year names like 2001, 2002, something like that, I don't have that information here. I have only in the form of keys. Okay, foreign key relationship. This is the primary key of the dim time table. I'm taking the help of dim time table to join with the fact internet sales in order to get the year information. I can filter, I can pass only 2001 if I want to filter 2001 data. I cannot pass finding out all the keys that belongs to 2001. To filter based on 2001, what I have to do? If you see here, I have to take all these keys and copy in the where condition. Can I do that? Is it the best way? That is not the best way. So I have to join with the timetable. Let's see how to do that. Sales. In most of the cases, the time key will be directly available. Like instead of 1, they will maintain 2001 or 2002, something like that in the fact table itself. The year itself they will be maintaining. If that is the case, your work will be easy. Why? Because you can directly filter, or else what you have to do is you have to join dim time on dim time dot time key is equal to fact internet sales dot order date key. Now what this has done, this has joined with the time key. This one will help me in taking some columns from the dim time table. I'm taking calendar year is equal to 2001. So what this is gonna do? This is gonna filter where calendar year is equal to 2001 data. So let me copy this for the remaining partitions. So fact internet sales, I'll name it as 2001. Finish. A partition is created. Now let me create a couple of other partitions in the same way. So here again, I have to join with kind of time and everything where year is equal to 2002. I know I have 4 years data, 2001, 2, 3 and 4. Let me create 4 partitions for that. So selecting the table, specifying the rows, and here it is 3. I'll name it as 2003. Finish, and I'll name it as 2002. I missed to name it. Done. And the last partition, that is for year 2004. Finish. The name of this one is 2004, which will give proper meaning to the people who works in the same queue. Now I'm done with the 4 partitions. As per the database that I have only 4 years data, that is 2001, 2, 3, 4. If you think our work is done, okay, then we are wrong. So what we have to do is, there may be chances chances are there to get the data where the year is less than 2001 in future. If you get any records like that, that will be missed. So to be on safe side, where calendar year less than 2001, this one will help us in getting less than, I'll give the symbol, sorry, less 2001. Okay, and I have to create one more partition for the data that is coming for the years greater than 2004. If you see greater than 2004, I'll name it as greater 2004. I don't want to design aggregations now. Fine. If you see, the first partition will take care of the year, that is data of which has the year 2001. Second partition 2002, 3, 4. And the fifth partition will take all the data like 2005, 6, 7, 8, 9, 10 up to 2099 or 2099, whatever it may be. Whatever the date that is year that is greater than 2004, if you have any records with that information, this partition will read the data. And this partition will read the data which is having year ID, calendar year less than 2001. It may be 1900 or 1800 and something, whatever it may be, less than 2001. So last 2 I added to make sure that all the records are read. There is chances, right, to get data which is less than 2000 in future or greater than 2004. So we cannot restrict that kind of information. So this is the safe side. You have to be on safe side. You have to make sure that all the records are read. If you all the records will be read if you process the queue. So this is how you can create the partitions based on dates, that is year. And most of the cases people go for partitions based on months, most of the year. People may ask you based on what criteria you create partitions. The criteria what I check generally is, I'll check how many records I'm getting per month. Okay, if I'm getting 20 lakh and above records per month, then I will create partitions monthly. For every month I will create partition. Okay. If I am getting 20 lakh or more records per week, then I will create partitions per week. That means in filter condition, I will filter based on week. If I am getting 20 lakh records or more per quarter, then I'll create partitions per quarter. That means in where condition I will use quarter. Okay. So why like this? Each partition should have a minimum. I mean, that's the best practice, or else you don't need to create partitions. Okay. Partition should have a minimum of 20 million, 2 million records, or even if you have more than 5 million records, that's better. But make sure that it is not too less, like 1 lakh or 20,000 or 30,000 records. So if you create partitions per month, it will be like this. 2001, January 1 will be your first partition. That means where year is equal to 2001 and month is equal to 1. Next thing, where year is equal to 2001 and month is equal to 2. Year is equal to 2001 and month is equal to month is equal to 3. Like that you will go for 12 months for 2001 and 12 partitions for 2002, 12 partitions for 2003, 12 partitions for 2004, and the last one greater than 2004 and the first one less than 2001. That means 12 fours are 48 plus 2, 50 partitions will come into picture if you go for month wise. If you go for quarter wise, year is equal to 2001, quarter is equal to 1. Year is equal to 2001, quarter is equal to 2. Like that you will get 4 per annum per year. So that 4 into 4, 16 for 4 years and 2 extra partitions to pull the data that is outside of these 4 years. That is total 18 partitions. If you go for semester wise, you will get 8 for 4 years and plus 2, total 10 partitions. Okay. This is how you have to find out how much data you are getting. If you are getting good enough data to create partitions per monthly, then go over month-wise partitions. And there is no restriction like you can create only 10 partitions, 50 partitions, 100 partitions. In SQL Server 2005, there was a restriction. Per measure group, they allowed only 2000 partitions. That's the maximum count. But here, after 2005, that is 2008 and R2 and 2012 versions, there is no limit like you can go for only this many number of partitions. It is limitless. You can add n number of partitions that you need. Okay. If you have 10 years of data in your analysis in your data warehouse, and if you go for monthly, then the number of partitions that will be created is 12 into 10. 120 partitions will be created. I have done this for 10 years. The condition was like this, where year is equal to 2000 and month is equal to 1. Year is equal to 2000 and month is equal to 2. Like that, I have created 120 partitions. Okay. This is how you create partitions. Now let's go back and see why it will improve the performance. First, let's see while reading. This is your application and this is your analysis services. While reading the data, if you have only one-to-one, only one connection will be set and it will read 1 lakh records per second. If you have more partitions, more connections will be set. More means don't think that if you create 2000 partitions, it will create 2000 connections. Parallelly, it will go over 5 connections, I guess. Okay, 5 lakh records per second it will read in that case. So the cube will be processed faster than having one partition per measure group, right? Will you agree with that? Yes, everyone will agree. I know that. And now query wise, how it will improve the performance. If I write an MDX query to pull the data from here, okay, if I write an MDX query, in my MDX query, where condition, in where year is equal to 2001, let's assume, that is the filter I am giving, okay, where year is equal to 2001, then it won't go into the complete data. It will go into the data where the partition is holding 2001 information. So complete data, let's say you have 50 crore records for 10 years information, and if you are requesting for only 1 year, then how many records will be there? On an average, it will be 5 crores. So which one is faster, getting the data from 5 crores or getting the data from 50 crores? If you request for 2002, it will go only to this partition and get the data. If you request for 2003, it will go for only this partition and get the data. 2004, only this partition. So what I'm trying to say is the query will be executed not on full data. It will execute on only partial data, the data that is available, that is present in a particular partition, where the filter criteria of that particular partition met with the filter criteria that you have given. So that's why if you create partition with the date based on dates, that is the months or years or quarters, as most of the BI guys love to see the data, I mean data analysts or business analysts love to see the data based on dates. So it will be very helpful if you define it based on date wise partitions. Okay, this is why the query performance will be increased, and that is why the processing performance will be increased. So partitions will help us in both the ways, improving the performance query wise and processing wise. So this is complete picture about partitions. You can create n number of partitions. Okay, and per measure group, there is no limit, which was there earlier. Now let me go to the storage mode. You can see standard, molap, and set the option. I'm setting the option to molap. It was rollup. Okay, that's why it was not showing anything. I'm setting the things, I mean storage mode to molap. Now let's process this set of partitions and see how many records will be read per partition. There is some error. Let's see what is that. Maximum number of partitions in a measure group, the install server conditions. Okay, this install server is, dummy one, I guess. Process, deploy the one. Yeah, that's one, man. It allows only 3 partitions. This is a different dummy server install, it seems. Let me remove these 4 and try to process the same. This looks like really you will not have the same problem. You can create a number of partitions. Okay, you don't worry about that you have to create only couple of partitions like this. So view details, it is not showing. Let me reprocess and show and see whether it gives the data or not. This version is not good. Okay, try at your home. I mean, whenever you get chance, whenever you create partitions, and try at your home. Okay, and this feature, without this, I mean, whenever the people ask about the performance, the first thing that should come into your mind is partitions, creating partitions. Why? Because this is the only one in different performance gain in improving techniques. This is the only one which improves the performance both query time and also processing time. So always remember, the first one that you should tell whenever people talk about performance is partitions in SSAS. So that's it about partitions, and we're good to go. I mean, you can start practicing the partitions, and in next sessions we will discuss about different concepts like aggregations, perspectives, translations, and also we have hierarchies. That is very important. We will cover that one in our next sessions. Thank you.